Hello, this is Ishan now, back for another video. I'm a programmer from Team 8720. Insert your name here at Evergreen Middle School. Today, I'm going to be showing you guys an autonomous program. It's going to be a linear op mode because I think that it's much easier to program an autonomous linear op mode than it is to use an encoder. So that's why I like to use linear op modes. But if you don't already, I like to do the easier way of stuff if it doesn't detract from the overall quality of the program. Um, since linear I always take the harder option if it's actually better, but I think that for this case, linear op mode is better. So I'm gonna call it tutorial. Once again, autonomous. So let's get started. Tutorial autonomous. We'll create a new class. All right, you want to do the same template that we did with the teleop program. If you haven't seen that video, I encourage you to see that. Extends linear op mode, right? There it is. And then the error, you know what to do. Public void run op mode throws interrupted exception. There's the boom. There's that. You want a little tiny. You want to add an override, and there you have it. There's your program. There's your template. Now you want to remember from last program we had. From here we had these three. Now we're gonna copy our op mode members, except for the integer because we probably won't need it. For this, okay, so we got this. You had to import a new class. Now we have this. We'll just take it from this again. Just gonna copy that stuff. Once again, I encourage you to watch the Telia basics before you watch this video, because we're going to be taking code from the we're going to be taking code from the teleop and putting it into the autonomous. But it's really it's not that hard. You set up most of the stuff the same. So you have that. You want to put in here, right there. Okay. Now wait for start. Now this is where things are different. Before you want to get started into what it actually does once you press the play button, which is wait for start, and then while op mode is active, we're gonna have to call it what we want. So which is at autonomous. This is an autonomous. Give it a name so you can actually see it on the driver station, and give it a group if you want. This is optional. I like to just put it all into FTC. After you're done that, it's time to actually get the actual program. Actually, what it does. So in this program, I'm gonna show you guys how to do for it to like drive forward, turn left, drive forward, turn right. But yeah, so that's what I'll try to show you guys. So wait for start, and then while op mode is active, there it is. Then there you have all the stuff. So in here, you want to create public void Wait, no, I don't think it's in here. Sorry. It's in here. Public. Is it in here? Yeah, sorry. My mistake. You had to put it in here. Public void. And then you're going to create some methods for this program. So you want to drive forward. I'll call it drive forward. And then in parentheses, you want to call it a double power. So double power. So this is saying that the value of power can be a double, which means you can use decimal points, which will be handy. So you just like to drive forward, you have to logically think what motors will I have to use and which direction and what will I have to set them. So if it's a double power, that means that drive forward, no, drive forward, that means that to drive forward you need to use your left wheel and your right wheel. So left wheel is set power, and then inside the parenthesis you want power because it's a double power. So this is the variable right here. You can change this to whatever name you want, so I'm just gonna call it Po. So let's just see what happens when you call it Po. See, that'll work, but I just call it power to just, keep it that the same. Now you want to go another way, public void. You want public void. How about turn left? How about turn left? And then we also need that as a double power. How about that? And then oh, forgot that you have to add right wheel. My mistake. Right wheel also has to be set power. Power. There you have it. Now to turn left, one of them is going to have to be negative power, and one of them will have to be positive power. So I'm going to start off with this is the power. It may be different for your robot, but you can adjust it for your needs. So set power, this would be negative power. So essentially, one motor is turning forward while the other motor is turning backwards. On most robots, that will cause it to turn in one direction. That will enable it to turn left or right. Keep in mind again that the negative might have to be in here instead of here. Now let's move on to public void. Let's move on to the next one. Public void. Turn. I'm gonna call it turn right. You can name it anything you want. I just like to keep these names. That's how I like to format. Double and then power and boom. And then in turn right, it's basically this, except for this is negative and this is negative. And let's just, since we have the time, let's add public void. How about drive backward? Let's add a drive backward. So you're creating a little mini library of commands you can use in your actual like section where you actually like play everything. So yeah, so this is just like a little mini library. That's how I like to call it. So drive forward. Oh, this is an error because using a command 2 times you can't do that. Backward. There, that's better. Now left wheel is basically this instead of this, like that. And then but this time you just want to set it negative. Now I'm gonna show you how to do a servo. Like, what if you don't want the power to be a decimal? What if you want it at an exact value every single time, so you don't have to enter the same value every single time? So I'll show you what to do if you just want a let's say raise servo. Servo raise. Let's just call it public void servo raise. Okay, and then in here, if you wanted to have one value specifically, and only one value, then we can just have it as claw, which is our servo, to set power, set position because it's a servo. How about 1? Now, if we don't want now, that's so every time you write servo raise in here, it will always set position to 1. Now, if you want to change that, you would write double power, and then you don't have to write power, but you have to make sure whatever you write after the double is inside the parentheses instead of a numerical value. So, and then let's move on to the next one. Public void servo lower. We're not gonna make it a double. Claw dot set position -1. Now, if none of this makes sense, please put it in the comments. I'll explain it to you. I'll try to get back to you as quick as I can. So, after we've programmed all of this, we can now use it. So, what you want to do is how you want to set it up is inside here, you want to say drive forward. It's in our commands. And then inside the parentheses, you have to write something that, like what value do you want to go? So, if 1 rotation. This is power is 1, that means the motor will go 1 rotation. So both motors are realistically just setting power to 1, okay? So after that, you don't want to go on to the next thing. You don't want to just go quick to drive backward. You don't want to go straight to drive backward. You don't want to drive forward and then drive backward. What's the use in that? You want to first have it sleep for 1,000 and then continue. Now I need to add one more thing. It's called stop driving. Actually, we don't need to stop driving. Actually, we don't need to use that. Um, public void. Yeah, we do. Actually, never mind. Stop. Just call it stop. This also is not a double, and this is just drive forward 0. So it's basically just stop. So it drives forward, takes a little nap, and then stops, and then continues to the next thing. So as you can see, stop, you don't put anything, but there's no error because it's not a double power. And then you can continue to the next block. It gives this is an organized way to write. And that's why I also like linear outputs, because I'll show you, it's very, very organized. So, how about turn left? How much you want it to turn left? How about like 0.5? And then you want it to be sleep 1,000 and then stop driving. So if you're getting tired of writing sleep and stop, we can create another thing called public void. This is the power of methods. So awesome. Total power. We'll call it total power, and then inside here we can write sleep 1,000, and then stop, and then stop there. See, so we can just use that. We can just use total stop or total power. Did I call it? I called it total power. Oh my god. Now, better yet, you can even put this inside the methods, but I think the fastest way is just to have it with just as total power. So you have total power, total stop. My god. Total stop. Nice. Turn left, drive forward, turn left. How about raise servo? Servo raise, yes. How about servo raise? And then total stop. And then how about it drives forward again? And so, oh, not DC motor. Drive forward. There. And then drive forward another one, and then you want to like total stop. And then you want to drive backward. Just a little, oh my god. Drive backward. Just a little tiny bit. Just like that. So you have it. There you have it. So drives forward for 1 rotation, turns left for 0.5 rotations, raises the servo, drives forward, and then drives a little bit backward. And one more step, you should just end it with a total stop. And there you have it. That's your program. An idle right here. So this is your basic autonomous program. So you can create your own mini library for your personal needs. This is a basic autonomous. If you have any questions, please comment down below. I hope you enjoyed this video and learned a lot from it. And keep on programming.